Hello everyone, I'm happy to introduce our work called non-urgent notification or non-urgent messages do not jump into my headset suddenly. Adaptive notification design in mixed reality. I'm Jingyao Zheng, and before we start, I want to thank to all my collaborators. Imagine if you are doing office work, say you are doing like the data analysis or coding, and then suddenly a mixed notification jump in your headset, and after viewing it, you find it's just like simply like the promotion email saying new season, new voices, and after viewing it, you determine it's kind of like the non-urgent notifications, and then you dismiss it. However, it's already like capture your attention and increase your cognitive load if you want to switch back to office work. I know it's kind of like frustrating and annoying, so we are here to solve the problem. There were quite a lot of like papers about exploring the effect on notification placement in virtual reality and mixed reality. However, none of them like promotes over like the adaptive notification system and test it across like different task activities. Lindsay is like propose a notification system like with different levels of details for the UI, while users have different levels of cognitive loads. Inspired by their work, we and also like the common technology ambient display, we proposed our work called like the adaptive notification system. As you can see on the left, this is kind of like default notification system you widely used in commercial like headsets such as Apple Vision Pro, and Quest 3. All notifications are were pushed like to users top view. So for our adaptive notification system, it's kind of like the urgency based. As you can see, like we have different positions, or this system determines where and how to show the notifications based on different like urgency levels. Here we provide more details about like the notification design used in our study. And in sub-figure B and C, we show details about like the non-urgent notifications. Initially, the application icons were positioned outside the user's periphery, but remained within a comfortable region. So users can simply click it to see all the notifications in the notification center. And for moderate urgent notifications, the messages were placed on the user's dominant hands. And subfigure E and F show like the notifications, very urgent notification placements and notification um, like design. Initially, notifications appear on the left side, and these notifications undergo a smooth 2-second transition to the user's central view to capture users' like attention. However, if users has already noticed like the notifications, they can use gaze or gesture to pull the notifications in front of them. So it will be easier for them to view the notifications. For like the environments and tasks, we provide more details in these slides. So we chose three kinds of like the environments, to open, semi-open, and close. For the maze, we prepare a physical 8.8 times 6.7 meters room free to obstacles. So users can walk in the maze or walk in the physical room to simulate like the walking like activity. For the primary tasks, we selected three categories, like the most common for virtual reality use cases and like the real world activities, gaming, problem solving, and learning. So for the gaming, we chose ball collection and count two for problem solving and reading and comprehension for learning. And the secondary tasks, like we users need to view notifications and access the urgency levels. If notifications are deemed as like non-urgent, they could dismiss notifications or simply ignore them. If notifications are moderate urgent, they need to interact with notifications after completing subtasks. If they consider notifications are very urgent, they need to respond to the notifications immediately. And here will be like the whole procedure of the study. And after following the welcome and informed concept signing, we introduce the experiments to users and explain the definitions of urgency levels. And Before the formal study, users need to like classify the urgency levels of 90 notifications to help us to establish the baseline. And we tried to mitigate potential biases. So we paraphrase the 60 notifications used in formal study and added 50% more notifications. Since we are that, and then we provide like the virtual reality system tutorial, we build an introductory scene to help users get familiar with the interaction and reminding them to carefully read the sensor and contents and independently determine the urgency levels. So if they consider notifications of non-urgent, however, the system consider it's kind of like for urgent notifications, it's totally fine. They can just like dismiss it or simply ignore it. And then for the formal study, we do a dating square counterbalancing and then followed by the post hoc questionnaire. And thanks to the all the users for participating in the user study. Like for the formal study, we didn't use like the AI system since like AI system kind of they can induce like more noises. For example, like for the same content and the sender, they might have like different they can they will have, they might determine like it could be like immediate like moderate urgent for user A, but they can determine it's very urgent for user B without knowing user's personal information. So it might cause like the noises. And the second reason is like if we want to have like more personalized notification classify, we need a user's data, kind of like the past interaction data. So we can know user profile more. We can know and also like fine tune the classifier. Otherwise, like the users have like kind of like different preferences. It's kind of like if we use general AI system, like uh, it's not worth to do it since like per label notification class of notification data sets will be like more controllable. For the results, like we reported, like the NASA TX SUS notification mechanism, notification in virtualized questionnaires in this slide. As you can see, like in subfigure A, like adaptive notification system cause lower mental and temporal workloads and the frustration, but introduce like and also like the users consider the adaptive notification system has better performance compared to the default notification system. And in the figure C, as you can see, like users considered an adaptive notification system provided more wanted information, and they found it's kind of less disturbing and it's kind of like more comfortable while with others. And figure D showing the users consider adaptive notification has high understandability. And here will be like the results from logistical regression curve, which is like the most ex interesting and exciting like part of our study. We evaluated how users perceived urgency aligned with our per label urgency levels. Since we consider like users like acceptance like their acceptance rate to the adaptive notification system could be somehow like related to like the model's like the performance, or we can call it disruptiveness or omission. It's kind of like different ways to evaluate classification rates of the system. And here we determine notification was marked as like the misclassified if a non-urgent message was interacted with within like 30 seconds. And a moderate urgent message was like not interacted with within 30 seconds, and very urgent message was not adjusted within 15 seconds. So here we give like 15-second buffer for like notification interaction and also 15-second buffer for subtask completion. And here we define like two different like the terms to represent like the adaptive notification system performance, or we can call it accuracy. One will be like the omission. It could be like the percentage of truly urgent messages misclassified as non-urgent, and disruptiveness, which could be like the opposite like condition. Here we found like the sum of disruptiveness and omission like has kind of like logistical regression relationship with like users' preferences about like the adaptive notification system. So it draws conclusion or kind of like implication about the future design, like perfect AEI classification may not be required for users to accept like the adaptive notification system. And also like this balancing disruptiveness and omission may matter more than achieving high overall classification accuracy. And based on like NASA TORs and the notification mechanism, and also like the notification in virtuality, and we consider the spatial attention hierarchy is needed, and it should be like urgency, at least urgency based. And for our work, we think the reason we chose like the urgency rather than importance is mainly because like the urgency is kind of like short-term impact, and the importance could be represent like long-term impact. So we chose in urgency. So we and also we acknowledge the limitations in our works. The first thing will be like the pre-labeled notification data set. Since we didn't use the AER system, so it could be like users might find so like the AER system can be like not acceptable, or it can cause like the noises as mentioned earlier. So it might determine like it might affect users' preferences. And the second thing would be hardware constraints, since we use class 3 in our study, and there will be a kind of a lot of like hardware constraints for like the future use. And the last thing and then the most important thing would be like short-term laboratory study. Since we only simulate the notifications and we can't simulate the potential causes caused by the misclassification. So like for the use for the future study, like they like the future for the future study may consider like the longitudinal real world deployment to further explore users' preferences with like the relationship between users' preferences with the model's accuracy or like with the sum of like the disruptiveness or omission. So it could be like the very interesting part for the future research. And thanks for watching. So for further information, please refer to our paper like later. Yeah. Thanks very much.